Hey everyone, I'm Ali. I'm a third year computer engineering student at Concordia. Uh, I have been working for about a year now at Aquantix. I used to be their lead data engineer and software architect, and now I'm team lead for applications, which is honestly pretty great. I learned a lot of cool stuff on my time there, and I've done a lot of Python workshops in the past. Uh, at the Technology Sandbox, which I very highly recommend that you guys check out because it's a fantastic learning space for people of any single discipline. You could be interested in arts or any of the sciences or video games and so on and so forth, and it would just be a wonderful learning experience for you. All right, so the first topic I'm going to be covering is exactly what are computers and what do they do? Sorry about that. So, very simply put, the way computers are these big, chunky machines that somehow are able to do some stuff for you. And how they work is very simply because of magic. Ta-da! Well, the real reason is because a lot of smart people spent years and decades just perfecting all these nuances that come into making something compute on such a massive, powerful scale. I'll sort of get into a little bit more to sort of help you guys understand what massive scale I'll be talking about in my big data segment. But for now, just understand that it wasn't the work of just one Bill Gates or just Alan Turing, bringing the concept for computable of the Turing machine or Gordon Moore's transistor. It was a whole slew of people who worked throughout time itself to build what is today's greatest achievement, in my opinion. So, the way modern computer works is that there are a lot of different layers that come in, a lot of different layers in systems working together to sort of bring you a user experience. Everything is working with the help of a computer these days, and there are several different layers to it. The first one, the most common one, is the application layer. It's sort of like what we end up using. An example of that could be Chrome, it could be Discord itself, it could be Microsoft Word, it could literally be any single program that has been written running on a machine that works. After that, you have the algorithm. That's sort of the next layer of abstraction beneath it. And then you have the programming language. The programming language is what you and I generally code in, such as C++, Java, Python, JavaScript even. What these languages generally do is that they come into two categories. The first one is a compiler-based language, and the second one is an interpreter-based language. A compiled language generally takes all of your code and converts that into this big chunk of assembly language, which is very difficult to traverse and work around, but is extremely powerful. Generally, what you'll find is that compiled languages are much, much faster than non-compiled languages, or preferably interpreted languages. Interpreted languages, however, have a lot more flexibility to them, which allows them to be just as powerful. A great example of this would be Python and JavaScript. Python especially, because you can actually integrate a lot of different programming languages and programming tools to make it work together and have this amazing ecosystem. That is the Python ecosystem that's brought the AI revolution today. For those of you who may know this, Python is very, very slow to work with and do anything that is even reasonable, But a lot of smart people, what they ended up doing is that they wouldn't write the important stuff in Python itself. What they do is that they write a lot of the stuff in C or C++, and they set up a layer between C++ and Python. And this way, you can have C++ like speeds, which is amazingly fast, especially on modern day hardware, and have that communicate with Python, which is just super quick and easy to just get it up and running. And that's more or less how AI, for example, has been so powerful, is that you can write such complex algorithms, such complex programs in so few lines of code. It's honestly fascinating. After that, you have the assembly language. This isn't necessarily the same as the machine code. I'll get into a little bit of that later. The assembly language is just another programming language, but that's much, much more, I wouldn't say complicated. It's just much more specific. Not even that. To sort of help you guys give an example, the assembly language is sort of what you write in for operating systems, and what it's mainly used for is to be converted quickly into machine code, which is very specific to each single CPU itself. You wouldn't necessarily notice any major changes because technically both of them are sort of in the same level. I'm sort of explaining this badly. What I'm trying to say is that machine code is what you sort of need to work on the hardware itself. It's the final layer of abstraction between the software and the hardware itself, because it's literally just ones and zeros set up in hexadecimal, but don't worry about that. Yeah, so then we have the instruction set architecture. This is more on the hardware side now. You'll start seeing as we go down the list, it's just hardware. The instruction set architecture is essentially different for each individual machine. Well, not each individual model of a machine. What you'll see is that Intel's instruction set architecture is going to be much different from PlayStation 4's instruction set architecture. Generally, what you'll find is that programmers, when they want to squeeze every single bit of performance out of a system, they generally work on the assembly and machine code level. These two levels are perhaps the most important when building any massive enterprise level software, especially that's going to be working with any users. Yeah. Fun fact: your favorite Nintendo game was a good chunk of it written in assembly, and the beauty about it is, if you remember the Smash Bros. This is just a fact off the top of my head, but the Super Smash Bros. The first game, in it, there were they had very, very, very limiting memory constraints, and some of the stuff that they did to meet those memory constraints was insane. For example, the cloud sprites as well as the bush sprites were the exact same with just a change in the color itself. Yeah. So, back in the old days, I guess you could say that they did these amazing things for really just maximizing what they can do with what they had. And it's honestly a fascinating talk on its own, but I won't get too much into it. After that, we have the microarchitecture, gates and registers, devices and transistors, and finally the physics of it all. So, for those of you know, transistors were pretty much invented by Intel back. They were pretty much invented by Intel, and they're essentially what is the building block for any single electronic computing today. Generally, everything below, I won't go too much into about the hardware section of this because this is a programming workshop. But I will say that these are all interesting facets on their own, and I definitely recommend that you look into it. The lower you go into this graph, obviously the order of complexity is going to be increasing. But yeah, all right. So after this, we now have, what do programmers do exactly? So in a very typical programmerish way, I would probably say, I have no idea what I'm doing. And for the most part, that's actually fairly true. What you'll sort of see is that programmers, they generally do two things. First is problem solving. In this, the main goal is to identify problems, explore different ways, select the best idea, build the best idea, test and build the best idea, and finally evaluate the results. To give you an example for each of these stages, let's say I want to build a chatbot. This is a chatbot for my website, and what I want to do is that whenever a new customer comes onto my website, I want them to be able to go through each of the whenever a new customer comes to my website, I want the chatbot to be able to talk to them and sort of figure out their needs and send them a link to the exact page that they want to go. So that would sort of come into identifying the problem or a new feature that I need to add. Next would be explore information and create ideas. So there are multiple different ways in which I can sort of like work on this to sort of achieve the best result for the problem that I have at hand. The first way would be to maybe get a degree in natural language processing, figure out the whole kablam of it, learn every bit of the theory as it comes, and just like spend years and years and years and years of my life just to build this one single chatbot by understanding all the complexities behind it. Another way of doing this is I can look at stuff that people have already created in the past and working with that and integrating that into my website. This is where the importance of open source libraries comes into play, because open source is this fascinating tool where people can write a piece of software, put it on the internet, and then other people in the world can take that piece of software, modify it, improve it, and build something really powerful together. This is essentially how Linux came to be formed, and it's this amazing, not just operating system, it's this amazing ecosystem and community that has achieved it's achieved a great deal. So after I look at my two options, the first one being I spend 10 years building this from scratch in any single programming in the hardest, most perfectest programming language, or I can use a pre-built solution for my needs. After this, I've completed the third option, which is select the best idea. Obviously, I'm going to spend the next 10 years of my life building it. So step 4 is build and test the idea. So it's been 4 weeks now, and my boss is starting to get annoyed at me because I still haven't integrated that chatbot into the website. And I can sort of tell that he's starting to get angry at me. So at this point, when I've built a very limited prototype that can barely take words in at this point. What I do is, at that step, I evaluate the results and I say, well, it probably wasn't the best idea for me to spend the next 10 years of my life, building this one tiny thing. And what I do then is I look back at what I did wrong, back to the explore information, create new ideas, and I realize maybe I should just use one of the prepackaged stuff. I build and test the idea, and a week later, my boss is really happy that, hey, you finally got that thing working, and bravo, congrats, and I get a medal for building a chatbot into a website. I look at the results, customers are happy, but there's still something for me to improve on my website. So this time, it's going to be it's giving me some issues when I order a new package. It's just not working for some reason, and I'm back in my programming job where I have to work on a problem, explore new ideas, select the idea, build, test the idea, and evaluate the results. Right. The next important thing that most programmers do is collaborate. This is especially crucial when you start working on bigger and bigger and bigger projects. What you'll realize is that you might be the best programmer there is on Earth, and that's true for me, not necessarily for all of you guys, but you sort of come to a point where you realize I can't do enough on my own. I need help from other people if I want to get this project done on time. An example of this could be, let's say you're given 3 months to build a web app start to finish. What you sort of plan is, okay, this is going to take me 1 year to do if I do it alone. So your boss says, you know what, the client said he wants it in 3 months, and your time estimate is 1 year. I'm going to hire 5 more people just for the hell of it because we have some extra cash thing, or we're going to hire extra people. Then what you're going to start doing is you're going to be collaborating. Now your timeline has sort of been made shorter. And in this time frame, there are a lot of different things that you can do for building the entire pipeline or your app. Some components of it would be the front end, the back end, the database, and so on and so forth. Different programmers have different ways for collaboration. There's the Scrum methodology, Agile, Kanban, so on and so forth. There's also the pair programming, in which you and another programmer sit on one desk side by side, and you guys work on the same problem. This is generally helpful. Because what ends up happening is that two people can work on a problem faster when they're working on it together than when they are doing it individually. It's really effective when two people of two different disciplines. Let's say I'm perfect in backend development, and my friend is really good in front-end development. And we're trying to fix this bug in which whenever from the front end a request is made to the back end, it's just not being processed properly. At that point, you guys would do something akin to pair programming, where you work together and try figuring out what the problem is. A good tool for collaborating on larger and larger projects is to use Git. Git is this amazing tool that I honestly recommend every programmer who wants to, get started on his career to learn and start using tools like GitHub or GitLab. Essentially what it does is that it lets you work on ideas and projects for multiple people and make sure that whatever you're submitting works. So, one second. So how it works is that let's say you have a text file that contains your code, and another person comes along the way and says, hey, let's work on this together. So you guys work on this together, and both of you make a copy of it using Git on your machines. You modify the top half, he modifies the bottom half of the code, of the document. When you merge together, Git is going to say, hey, these two things make sense well if you look at them. If I merge them together, it's probably going to be working fine, and there's no merge issues that I see. But let's say you're working on the top half, and you modify some of his code to make your code work. When you guys merge together, what you'll see is, hey, there's a problem with this. It's not working for some reason, and that's a git merge thing. Git merge conflict. So you guys work on the merge itself, and you identify that there was a problem. We solved it. It's working. It works on a really beautiful and complex system, which I highly recommend newbies to start learning. It's just really fascinating, and I really suggest that you guys learn it as soon as possible, especially if you're going to be working on projects together. So some examples of programming problems is app development and big data. So app development these days is pretty useful. Obviously that's what you use to make websites, apps, and honestly, apps are pretty much used for everything, including TVs. Big data, on the other hand, is this fascinating concept where we have all of this information that's being generated every single day, and people are just trying really, really, really hard to figure out ways to be able to get interesting results so that they can help people and build better tools or something along those lines, right? So, application development generally breaks down to 3 separate steps: front-end development, back-end development, and DevOps. Front-end development is essentially just building the user experience. These are the common tools that I've seen be used for web development. There's a whole different set of tools for Android development and mobile development in general. So JavaScript is sort of the language that you use to make everything. How do I explain this? JavaScript is what you use to make everything talk and everything work together in an interactive and flexible manner. Vue and Quasar are what you use to develop the front end and make the application actually look nice and make it be flexible. Note that there's a difference between having it look nice and have it actually be functional and actually have it be something that's easy to change. That's where Vue and Quasar tend to excel, is that the way they build their entire ecosystem is to focus on flexibility and modularity. let's say I built something on this one page and I want to use it somewhere else at a later date. Vue and Quasar will let me do that with much more ease than if I had written it in pure HTML and worked on it that way. Really interesting and really good tips, especially if you want to get into front-end development. Again, there are a lot of other tools out there, but these are the ones that I've primarily interacted with. After this, you have backend development, and this is frankly one of the more interesting parts, in my opinion. I primarily worked with these three tools: Python, Flask, and PostgreSQL. As you all probably know, Python is a programming language that is used literally for everything. I could not emphasize this enough. 1 second, let me check the chat and see if anyone has a question. Okay, well, if you guys have any questions, be sure to put them in the chat. So, Python so how do all these three things work together? Well, Flask is essentially a library that posts API information to the internet. And with that, you're able to pull information from a database. So to give you an example, think of it as three more layers this time, where Flask is sort of talking to the internet up here. Postgres is the database that contains all of the information, and Python is the programming language that you use to make everything work together. So in an example, I would probably say, let's say your front end, you're building an app to take customers' orders for this company that is totally not Amazon, but is still Amazon-esque. And what you do is, and what you're planning on doing is, when a customer adds a new item to the shopping cart, what you want to do is you want that to be sort of noted down in the database so that when the customer views it from a separate page, they're able to see that there's something that is waiting for them. So here's what happens. The front end sends a message to the Flask API, and it says, excuse me, it says, hey, for customer ID number 12345, I want to add an order for XYZ. Flask is going to receive that request, and it's going to interact with the Postgres database written through Python that, hey, for this customer with this ID, I want you to add item this inside the database. So then when the customer goes to a different page, say the cart page for the website, the front end sends another request to the Flask application saying, hey, give me all the things that are in this user's cart. Flask will then talk to Postgres again through Python, asking for this specific list of items in the list and return that to the front end. The front end is then able to look at it and render the item itself. Through this, you have the entirety of how the backend development sort of works. Generally, the tool that you use to talk in the front end, is JavaScript, and Vue and Quasar are the components that you use to talk to display all the images and stuff, so that all these three things can work together. 6 things technically. But this is just an example. Again, there are a lot of different tools out there, such as Django, that you can use to build your entire pipeline. There is sadly no one tool fixes all to solve every single problem, but I would say Python is the closest to that tool because of how flexible it is. But even then, it's just really good for this one small subdomain of problems. There are a lot of different tools out there. So after this you have DevOps, and normally I would be asking if any of you are familiar with DevOps, but yeah, any of you know what DevOps is? I just want to try this out, see if anyone wants to just pipe in. Go ahead. Okay, so DevOps is essentially, I would say about 30% of my job is writing new code, only 30% of it. The next 30% I would probably put pretty close towards debugging, and the remaining 40% I would sort of put it towards maintaining the code that I now have. What that sort of means is that I have some code that I've written in the past, and it is susceptible to breaking because, well, life is ever changing, and so is somehow my code, and I don't know why it's breaking. To sort of fix these problems and make sure that they don't occur and it's not a huge problem for me, what I generally tend to do is utilize tools that let me test my code application so that when I do launch it to my clients, they can use an app without seeing it break. There are a lot of interesting concepts here, but I just want to focus on the tools themselves so that you guys can look onto it in the future in your own time and sort of utilize that knowledge. So let's keeping in mind of my Amazon-esque application where I essentially have my app, but it's not really running on a server. Now, there are a lot of ways in which I can set it up, and what I plan on doing is, okay, Google Cloud is this amazing thing by Google that lets me spin up a server and run whatever I want on it, and I somehow expose that to a specific URL, say myshop.com / the best shop in the world / haha Amazon Jeff Bezos who, am I right? Wink wink. Yes, that's a long URL, just go with it. So what I do is essentially I set up a server, my web server, that talks to the entirety of the internet, and customers can go to this link and view my website. Now, let's say I make a change to it. I add the chatting feature that we were talking about, and what I want to do is essentially have that. One second, let me check the chat. Speaking of that, sorry, and I want to make an update to it. In this case, I would simply use GitHub to just push the latest version to the server, and my clients can now see the latest version. But what if I end up making a mistake and my clients end up suffering? Let's say my client ordered only one case of hand sanitizer, and for some reason they got 1,000 cases of it because there's some bug in the backend. And now there's a massive shortage of hand sanitizers, and everyone is bulk buying them. And here we are in 2020. So what I can sort of do is set up CI and CD tools. That's CI stands for continuous integration, in which you can have 10, 20, 30, 100 developers working on something, and every time they make a change, it's put into GitHub, and whenever that happens, it automatically runs all your pre-written tests for you and makes sure that your application works without any issues. And then when you push from Git to your web server, what you realize is that, hey, my website is working fine and dandy. I know because all of our test passes and any bugs that come up were just very, very minimal and just on the very low off chance, right? Sorry about that. Let me just turn my volume down. So that works fantastically. But let's say you have two developers working on a problem, and suddenly the first developer goes, "Hey, this piece of code isn't working on my machine for some reason because, well, I don't know why it's not working. It's just not working. Can you help me out?" And the programmer 2 says, "Well, it works on my machine." That's sort of the issue that came up quite a lot. And the way people have been sort of working around that is by utilizing this amazing new technology called Dockers. Dockers is essentially, I'm going to be hosting a workshop on it in a couple of weeks, which I hope you guys are there for. Hopefully this workshop does not sour your taste to my other workshops that I may end up doing. Yeah. So in that case, that's where continuous deployment comes into play. What continuous deployment does is that it will build this Docker image. Oh, I should probably explain what Dockers are. Docker is essentially a virtual machine, but a very stripped down version of it. It's essentially running a very minimalist, it's running absolutely nothing, except a tiny bit of code that lets it interact with any single Linux or with any single operating system's kernel, and based on that, just interact and work with and just run whatever you want to do. Sort of give you a better example is that once all the continuous integration tests have passed in my CI/CD pipeline, which again just tests out my entire web app and make sure that everything's working, what I wanted to do next is automatically deploy to my Google Cloud server. Oops. The way I'm planning on doing that is that whenever the integration is done, I wanted to build a brand new image and put it directly on the server itself. That's where continuous deployment comes into play. What tools like GitHub Actions would do is they would automatically start building a Docker image, which is essentially a bunch of commands that are run one after another, with the main goal being to execute, to set up an environment where your app will run 100% of the time, and deploy it onto the virtual machine, which will always be trying to talk to a cloud service, usually called sometimes Docker Hub, sometimes Amazon ECR, sometimes Google's own solution for it, and so on. And based on that, it will always be catching the latest version of your deployments. Does that make sense so far? Let me know if you have any more questions. I'll be more than happy to answer them. This is, again, a really interesting concept, and I hope you guys will look into it a little bit later on. I see someone is typing. I guess I'll answer your question when I get to it. So, after this is the much more interesting big data. So, one second, I'm going to have another sip of water. So, what is big data? Every single day, there are exabytes of data that are generated, and generally people are trying to gain some insights from them. An example of this would be a hospital administration where they have information on hundreds and thousands of patients, and they're trying to find out maybe like what's all the common symptoms between all of the COVID-19, from all the people who were sick from COVID-19. What symptoms do they have in common? What previous issues did they have? They could try creating machine learning models that work on this massive amount of data and try inferring some results, and based on that, maybe they can try working on a new vaccine, for example. This is just a lot of data that is just very, very hard to wrap your head around because of its massive size. And generally what a lot of people have tried to do is that they try breaking this complex bunch of information, and they try breaking it down into workable components and parts. So let me give another example because I kind of feel like I'm not being clear enough. Let's say I have a text file that contains 1,000 words, and I want to get a list of all of the words that have an even number of letters in them. So what I would be doing in this case is essentially looking at all my, so there are multiple ways to do this. I'm going to be going through each individual word in the file, and I'm going to be creating two separate files from it. The first file is going to be containing all the ones that have an even number of letters. The second one is the one that does not. I go through it line by line, and I just keep checking it one after another. I'm doing this manually. It's super slow. It's just not efficient at all. And more importantly, it's not scalable. Let's say instead of 1,000, I have 1,000,000 or even 1,000,000,000 a text file with 1,000,000,000 words, and it's just really hard to sort of imagine us, a single person going through those many words and noting down that massive amount of things. So what I do is that I call up my friend Steven, who sort of owes me a favor because I did this workshop for him this one time, and I ask him, hey, I have this massive text file, and I need to sort of figure out all the even words and odd words and put them into these two separate text files. And Steven says, man, you're crazy. I don't think even I can do that. The two of us can do that. So what you do is they invite two more of their friends, and so on and so forth until we say, okay, now we have enough people to work on this problem. Let's all work on it together. That's sort of similar to how you work with big data computing. Is that you, instead of working on one single laptop or one single machine, what you do is you take the massive task that you have at hand and you break it down into much smaller pieces and have a lot of different people working on it to get a lot of different servers and machines working on it together and break it down accordingly. So instead of each single person doing 1,000 words, they're now doing, say, 10 words at a time. So this sort of brings up the question of, hey, I'm really interested in big data and I really want to get started on it. How do I sort of start doing that? So I'm going to be just talking about the tools themselves. If you want to get into big data and start working on them, I really suggest that you look into them. The first one is the Amazon EC2 instance. This is this really powerful. Oh wait, one second. Let me just try showing you instances.aws. So I'm just sort of going a little bit off right now, just to give you guys a example of what I'm trying. Please don't hack into my account. All right. So what EC2 lets me do is that I can now create a single server, or how many ever servers I need, running whatever version of Linux that I need. I have this massive collection of operating systems for me to choose from. Let's say I want to spin up a server for Ubuntu for deep learning purposes, or let's say I want to pick one. Let's just pick a normal Ubuntu 18 server. I select it, and now I can say which type of server I want to use. This sort of comes with a massive list of servers that I can just pick up right out of the box. Let's say I want one that's like super powerful, 128 cores and about 4 terabytes of RAM with about another 4 terabytes of SSD storage, right? No, I'm not going to actually launch this because this is going to be super expensive for me. I'm a very, very poor boy. Now, next, I configure instance details, add storage. This is all just some stuff that you guys can look into later. Amazon does have free stuff for you guys to sort of work with on your own, and just for a learning experience. It's very limited, but it's still pretty useful. Review and launch, and I'm looking at the details over here. Oh, okay. Let's say instead of one instance, I want to launch, say, 1,000 instances. So what AWS lets me do is that instead of one server, I can now launch 1,000 servers. I'm not going to do this because I'm, not that, it just wouldn't be smart to do that. But this sort of explains that AWS will let me utilize and manage all these servers in such an easy manner that I can then do whatever I want to work on any big data problem. Another interesting thing is that most servers can also be configured for your purpose. So a lot of these are general purpose, but you can also have other types, say micro instances, FPGAs, compute optimized. Let's say you have a lot of stuff that requires it to be parallelized across a lot of different cores, and that's going to be really useful for whatever you're working on. Again, look back to our massive text file example. This machine would be really useful versus a 2 CPU one. Let's say I need to do a lot of AI operations on it. In that case, a GPU instance would be very useful to me for what I can do. Otherwise, let's say I'm just setting up a server whose main goal is just going to be downloading some data, getting some information from it, and putting that into my database. What I intend to do with that is just only use a single instance that is whose network performance is rated highly, say 12 gigabit or 100 gigabit which is insane. I wouldn't probably even use that for any reason, but it's just a lot of different cool problems that you can solve with these things, right? So that's sort of the tools that I can use to orchestrate me working on these big problems and working with them. After that, let's say to work on my massive data sets, like image data sets, how would I sort of store them so that I can train my machine learning models from? Well, that's where we come over here with MinIO, S3, and MongoDB. So I'll start off with MinIO and S3 because they're sort of in the same vein in terms of their usefulness. What MinIO and S3 are used for is to essentially store information in a manageable, is to essentially store any bit of information that you need so that you can then download it from any of these instances that you launch from AWS. So to sort of give you an example, I'm just going to quickly hop on to S3, scalable storage. Again, I can have literal petabytes or exabytes of data in S3, and it doesn't matter. It does not care. The speeds in this, which I can use to download stuff, is amazing. So actually, let me look at some GDL. Did anyone have a question or something that they were going to ask? I don't know. I just heard someone unmute themselves. GDL S3 bucket. All right. So those who don't know, every single news article on the internet is updated every 15 minutes in this amazing global database of events and language and tone called GDL. This massive data set contains every single article up to a couple of years ago. No, starting from a couple of years ago until today, it's updated every 15 minutes. And what they do is they store all this information in AWS. I'm trying to find the bucket. One second. I'm just going to try finding it because I think it'll be interesting for this workshop. Oh no, page one. What's the shot? It just occurred to me that I should show this to you guys because I thought it'd be really cool to give you guys an example. But link. I remember there was this really clever way in which I used to figure it out. Nope. All right. Well, it's online. If I find it, I'll send you guys a link to it so you guys can check it out on your own. It's a massive collection of data. It's all in CSVs and other formats that you can use to just work on your own problems. MinIO is the free and open source version of that, and what that generally encompasses is that let's say you have a bunch of hard drives at home and a bunch of laptops, and you say, hey, I really wish there was a way in which I can store all of my massive data sets into all of my hard drives at once, but I don't want to spend a lot of time configuring, working, and having them all work and interact with each other, right? So in that case, what I use is a tool like Mint, and I don't want to pay the exorbitant fees for S3 because I just want to keep this project as low budget, and I already have most of the hardware. So in this situation, what I end up doing is utilizing a tool like MinIO. Let's search for it. And what this essentially lets me store is any single type of objects that I can use and have it running on my servers at a massive scale. And it's essentially the same as S3, but the main difference being that I can, it's the same scale as S3, but the main difference being that it is run locally and is much more cheaper assuming that I buy my own hardware. You can also use this for other there are also providers that can let you utilize the storage, and it also interacts with S3 in a very nice way. So to sort of give you an example of how these things will work together is, let's say you have your massive image data set that you need to process on a GPU instance on Amazon, running on an Amazon EC2 instance. What you do is that you store all this information in MinIO or S3, and based on that, and once it's stored over there, what you say is, okay, so Amazon, my EC2 instance, please listen to me. What I want you to do is load all the data over the internet from these servers, from one of these servers. You specify what the exact location is going to be. It's going to download it over the internet, store it in memory as it works on this data set and does its AI predictions on it. Let's say it's for cancer prediction. And from there, it's able to, without storing a single byte of data on the machine itself, it's able to just dump all that data when it's done with a machine learning, with a AI model that's able to perform exactly how you want it to, right? So once you're done with that, you can then store that AI model back on MinIO or S3, use it in production, find more vaccines for back to the COVID example, we can use it to find more vaccines and so on and so forth. All right. Then we have MongoDB. MongoDB is this really powerful database that you can also use. It's more for unstructured data, well, I wouldn't say unstructured. It's more for semi-structured data in which you can store it and work on it. I'm not going to go too much in detail because I've already spent quite a lot of time with MongoDB, with MinIO and S3, and MongoDB is still important for structured data for ETL platforms, for example, and it's on the same level of scale as EC2. So now you might be thinking, hey Ali, how do I coordinate all of these machines working together? That's a really good question, metaphorical person. And to do that, you use this tool called Kubernetes, or Q. It's essentially a container orchestration tool. And to sort of explain what that is, it's essentially, let's say you have a container for MinIO, which stores all this information. And let's say you have a container for your AI program. What you sort of want to do is have them be saved and backed up. But let's say you have you start running into problems where your one server isn't doing it, and you start adding 2 or 3 servers. And what you say is, and what Kubernetes is going to say is, hey, you one server, your main job is going to be to simply is going to be doing MinIO stuff. The next server's job is going to be computing. The next server's task is going to be doing MongoDB stuff, and so on and so forth. This way, they're all able to coordinate and work together and just just handle a lot of the hard work that you would have to do by yourself. And it's just generally a really cool way to just minimize your workload. A really interesting thing about Kubernetes is that let's say you have a cluster running right now. And right now, for every customer you get, it costs you $1. It costs you $1, but the customer brings in $2. So this way you're having a bit of a profit there, right? So what you end up doing is that you start realizing, oh my God, I'm getting more and more customers, but I don't know if my servers are going to be able to keep up. What Kubernetes does is that it can actually interact with AWS and say, hey, if our CPU starts going at 80% or what I'm going to do is I'm going to provision a couple more servers that are going to distribute the load so it stays low and my customer's experience doesn't go bad. And this way I can have my platform be built on this really flexible and on this really scalable infrastructure, so that there's never any downtime, right? That's sort of what Kubernetes is used for. I didn't want to bring it in over here because it wasn't necessarily related to the main thing, but it is important when you consider Dask. So for the uninitiated, oh no, I said dark. Dask. So scalable analytics in Python. So I'm sure some of you have at least worked a little bit with AI and machine learning in the past, right? So what Dask is essentially used for is it's what a lot of Python libraries such as these are using to make sure that your computing is done in a very scalable manner. And the way they sort of do that is, I'll just go into a very small and understandable way. Essentially, let's say you have a computing task that you need to do, in which you have an image to process for whatever reason. What your algorithm does is that it looks at each individual pixel and says, oh, if this pixel is less than this value, set it to 0, and if it's greater than that value, set it to 1. What Dask does is that it'll listen to this problem, it'll figure out this entire massive parallelization system, massive parallelization system, which will figure out, okay, so for this complicated task, what it needs to do is that I can tell each CPU core to divide up the process and work on it. I feel like that was a bad example. I'll explain a little bit more just to make sure that you guys are all following along. Feel free to stop me anytime in the presentation, or just message on the workshop group itself, and I'll answer that. Yeah, if you have any questions or whatever. So what it does is that it says, okay, there are these big chunks of jobs that need to be done in parallel, so it gets done super, super fast. What I'm going to do is essentially, whether you're using a laptop or using an entire massive supercomputer level cluster, what it's going to do is it's going to take that one task, it's going to send it to all the other machines, and all those machines, you guys can't see my hands, but it's up in the air. And all those machines are then going to be working on that image processing task in parallel. So instead of one machine taking 5 hours, it's taking 5 machines 1 hour each to do that entire task. And the way you do it is you still write the same Python code as you would normally, and Dask is taking care of literally everything else, from machine learning to simple data frame manipulation. It's very flexible to the point where you can either work on it on your machine locally and then be like, okay, this works really well for this small subset. Now I'm going to be launching it on this massive supercomputer that my work has for some reason, and we're going to be writing all of that. So it's also customizable, and it's used by all of these other tools, which I highly suggest you look into as well. X-ray especially is something really interesting. Scikit image processing is also another one. So, yeah, that's essentially more or less the entirety of big data and all the tools. And now I'm going to be sort of going over some of the programming concepts that I think are really interesting and useful for people. Right. So, first off, I'm primarily going to be explaining everything with the help of Python, which is a wonderful library. I've been using it literally almost every single day for the past, I want to say 5 years now? No, 6 years. Wow. That's pretty awesome. Yeah, I'm a massive Python enthusiast, and I highly suggest that you guys use this as your first programming language, because it's just this one thing that introduces you to so many different programming concepts once you start using it effectively. And then you can sort of go from Python to a more lower level language like C++ and Java with little hesitation and still sort of keep a lot of the core understanding of it. Or you can go into other programming languages like JavaScript and so on. It's really powerful, and the most interesting thing is you can do literally anything you want in Python. Off the top of my head, let's say mobile development with Python. I mean, you wouldn't want to do that because it's not effective and stuff, but there's probably a framework to do that. Great. Let's say beside that, I want to take suggestions. Anyone in the crowd, give me a suggestion of something you want to make. And let's see if it's possible to do in Python. Okay, web development with Python. Boom, there you go. Web development full stack Python. That means you can use it for both front-end and back-end stuff. That's actually pretty cool. Yes, Saud? Sorry, I'm just really bad at names, so I'm sorry, man, if I pronounce, or woman or whoever, if I pronounce your name badly, I'm just horrible at names. You can ask Stephen with it. Yeah. All right. Yeah. When I met Stephen, I think it took me like a week to learn his name, and I think I started calling him Stuart because he was helping us out at work for some stuff, and he was the littlest guy there, so it sort of became like Stuart Little. All right. So, oh yes, and please do make fun of Stuart as much, Stephen as much as possible, calling him that. Just
Damn,
a
you're
little
mean.
gift.
You're mean.
Oh, go cry me a river. All right. So, what is Python used for? Everything. Web development included. So, yeah. So after this, now I sort of want you guys to sort of follow along with me as well for the Python workshop. Oh, cry me a river, Stephen. So there's this really cool repository that I've used in the, not a repository, a website that I've used in the past to, oh wow, there's a whole thing going on in the chats now, guys. Brace yourselves. Or get popcorn ready. Essentially, there's this website, repl.it, which lets you just run an entire Python thing just right out of the Python environment. It's an online Python IDE. I suggest you look into it. It's just what I'm using for the workshop itself. I'm actually going to show them how to do it, Stephen, so you can give me a second to do it. So first step to go is to this website. I'm going to be, actually might be this one, just so they can follow along. And I click on it and click on the link, and it asks me to log in. I log in with my credentials, and what I do next is, all right, log me in. Oh, fields are required? All right, just log in through Google. Okay, new REPL, and I select my programming language. I have a whole list of languages I can choose from, which makes it really, really interesting and quick to develop on. It's an online IDE. I can specify the name, or I can import from the GitHub, and I can create a REPL. And now I wait for 1,000 years. Oh, thank you, Stephen. That's a good question. An IDE, one second, what is an IDE? An IDE is also called an integrated development environment. The main goal of this is when you start programming something, what you're going to quickly realize is that do you need to host a server to use Python like you do for PHP? Yes, you do need to do that. I can give you some stuff at the end of the. I can explain to you Heroku, which is this really cool platform that lets you sort of like host your own websites and stuff, and it's free for. I think it's free for like really, really small scale projects. So you can start using it, and then like if it's something you want to invest money on, it's fairly straightforward. I like having a lot more control in my projects, so I generally would just prefer with an EC2 instance. But again, it's your own. You pick how you want to do it. I really suggest this for beginners, however. So back to the IDE stuff. IDE essentially is when I'm programming on something, and I'm not just going to open up Notepad like I have over here with the notes. Just going like from operating system import list directory, and if I make a typo like RI, you don't need to host a server to use Python. No. Oh, okay, sorry. I thought you were. Okay, sorry about that. I thought you were asking if you needed to host a server to host a website or something. No, you don't need to do that. If you want to do Python, you can literally do it however you want it. You just need to have it installed on your system. So if I just type Python like that, it's going to show up over here that I have Python installed, and I can click on any of these tools that let me do this. No, you don't need to use localhost. No server, no nothing for Python. It's a program like any other program that you have on your computer. So Python over here, and now I can just execute it as a Python thing itself. So this is just a shell that I can use to type from, I can do print hello world. And now I can actually do something useful with it. This is pre-installed, but the reason I'm going to this website is that I know a lot of you might not have had Python installed on your computer, and I don't want to go through a 20-minute of how to install Python and get started with it. So just to make things easier for you, it's installed on my machine. It's really, really powerful, really useful. Seriously, guys, look into it. It's really cool. Yeah, so just to help you guys get started on where you can install Python from, you can just go to python.org. And by the way, Steven, how are we doing on time? I don't want to go over time, but I also don't know if I'm going under time.
You have an hour.
Just let me know.
You have an hour.
Oh, so I'm probably running close. Is there anything wrong if I go over time?
No, it's all good.
No, it's all good.
All right, that's actually pretty great. So yeah, it's really cool. It goes into all these, it's got tutorials for everything, the latest news. Oh my God, latest version is out. Sorry. Yeah. So you can sort of start developing an application that you want for Python just right out of the bat. No, the testing is out, not the actual version. We're still on 3.8.2. Yeah. So now I can do print hello world, and what you'll start seeing is that when I clicked on the print statement, it's actually starting to help me out with information on this function itself. Right. So print open braces. This is explaining exactly how I can use. Oh, right. Can you guys see better now? I think that's a bit too much. Stuart, you're my eyes over here. Is it better? It takes like 2 seconds. Fine. All right. So it's sort of cropping out of the top. That's fine. So yeah, an IDE will sort of start giving you information on how to exactly work with what exactly this does. So what it does is it prints values to a stream or to system.std by default. Optional keyword arguments, file, a place to stream the objects out to, separator, flush. You guys probably have no idea what this is, considering most of you guys are beginners, and that's fine. What this essentially does is it types out a thing to your screen, and then you can do anything with it. Hello world. And I hit run, and boom. Now I can actually display stuff over here. More importantly, there's a lot of other stuff that you can start doing with it. For example, if I want to do some math operations, say 5 times 1,000 or 10,000, I can get that. And then if I want to do the square root of it, to just quickly understand, what I do is star star, which is to the power of, by the way, to the power of 0.5. I hit enter, and just like that, it's able to quickly tell me the square root of it. So, a lot of Pythonic operations, such as math-based stuff, is done really quickly because it's done in C itself, especially for evaluating operators. So yeah, it's still not as fast as C because it's still an interpreted language. What that means is that, let's say I have a variable, say a name of variable would be, say, Steven. Steven is 5. Sorry, Steven, that's mean. And I want to find out how old Steven is going to be next year. So what I do is Steven plus equals to 1. Okay, I'll slow it down. Okay, ground zero. So you guys can see that I can do 5 plus 1 over here, and it works pretty fast, and it's pretty nice and all that. What I want to do next is essentially just figure out, now I want to say store this value of 5 plus 1 into something. Like in mathematics, there's this thing called variables in which I can store whatever value I want. So in this case, let's say I want to say, I want to save the value of 5 plus 1. This returns 6. If I type out 6, it's also going to return 6, right? So what a variable does is that let's have a variable Steven, and I want to store a value in it so I can use it multiple times without having to repeat the same number again and again. This is sort of like useful when you have a massive number like this, and you don't want to type out this thing, or you want to keep copy pasting this thing again and again. So what you do is you create a variable, say Steven again, and you say this is equal to this. So when this value is saved, you see that there is no longer a return value over here because it's returned and stored inside the Steven variable. I hope everyone's following along. If you guys have any questions, put it up on the group. Perfectly fine with me. So now if I were to just type Steven, now it's going to return the value of what was stored over here. If I do Steven times 2, it's going to return that to the power of 2. If I that times 2. If I do Steven to the power of 2, it's going to return 5,000,006. That's the whole thing that you guys may learn in engineering. So yeah, to sort of go a little bit of math nerdy on you guys, the reason why this is happening is because a computer can only store a finite amount of digits. So what it does is it sort of cheats and stores numbers that are close enough to other numbers. So it never stores just 50,000. It stores 50,000.0000006. And that's just a really clever way computers store like a lot of information. Yeah. So even though like 5,000 times 5 times how much is this? Yeah, 5 times 100,000 to the power of 0.5, and then I square that again. It's never gonna give me that exact number. So 5 to the power of 0.5 to the power of 2, and let me add some brackets so that it's easier for us to comprehend. Because otherwise, it's 0.5 to the power of 2. This is going to be 5,000,000,001. Right. So that's some really fun stuff. And hopefully you guys are familiar with how variables work. Right. How variables work and how everything works together. What else was I going to say? Let me check my list of things I wanted to go over. Control Z, Control Z, Control Z, Control Z. God damn. Okay. Fun fact, Notepad does not save your Control Z stuff for longer than like one thing. And damn. Don't save that. Okay. So now I'm going to be sort of explaining other programming concepts. One of them is keywords and built-in functions. So if I want to print something, it's a built-in function. What's a function, Ali? A function is essentially a piece of code that is written somewhere that you can run again and again without having to worry about it, without having to rewrite it again and again. Think of it like a variable for code itself. So the print function is in a similar way a function as well. It's a function, yeah. And Python treats like an object. So if I type print, this is essentially going to load up all the documentation on the print function, and it's sort of going to explain how it all works. Prints a value to a stream or system out by default. Say I want to print Steven again, because it's still stored in memory. It actually prints it out without any issue. Let's say I want to print Steven, comma, in quotes. Remember, we're using quotes because we're going to be saying something now, and you want it to be printed out exactly. Is a number. So this is a number, and that's what we're going to print out. This massive thing is a number. That is true. So Stella N has a question. In REPL.it, you can write code in both the black screen and the white screen. I should probably explain what both of these things are as I continue on. So the first one is the IDLE. which is essentially an interactive console where you can type something and in the next line you can sort of get a result back shown to you just like that. It's really useful when you want to like test out whether or not a certain feature actually does work right out of the bat. Let's say I have a list of numbers and I want to add them all up, but I'm not really sure if I can do that in one line or if I can do that in 2 lines, or if I need to do an entire for loop or something. Again, at the end of this workshop, I'll be showing you this amazing resource that'll help you guys get started with everything. Don't worry about it. So what I can do is, okay, let's say I'm confused about the print statement itself. So the problem is that what I want to do is I want to check if the separator is the keyword. Okay, so there's this cool feature in Python where Python doesn't care if you use single or double quotes, by the way. So what I want to do is I want to print out Stephen, comma is a number, but what I want to do is separator equal to this. So what this does is that so instead of adding a space over here, it's going to be adding the word this. This stands for separator, right? Makes sense? So when I type this over here, so it's going to say this number, like this massive number, which I don't remember, but was it the square root of something? Yeah, it was the square root of a number. Anyway, instead of putting the space this time, this is putting the word this over there, is a number. So let's say it's been a really long time since I've used this function, and I'm just trying to remember, how do I use this specific feature now? So I do print Stephen, comma, black, because I'm not going to type it out again. And what I do is I write separator equal to this. And I press enter, and it's like, hey, this is an invalid keyword argument for print, which means that this is wrong. So I try it out again. I'm like, I'm pretty sure it's sepi. And I type it out. Nope, still wrong. And I type it again. It's like, oh, sep is, okay, so this works and I can now use it. So let's say I have a pretty large program where what I'm trying to do is, so now I'm like, hey, cool, I now know how this works. So now what I can do is say Stephen equal to 50. Actually, you know what? Stella, for bringing up this question, I'm going to give you the honors. Stella equal to 50. So congratulations, you're now a 50-year-old person. So now what I want to do is Stella equal to Stella plus 1. And now I want to do print Stella. Right. Oh, so that was, sorry, Starial 128. What it does is, let's say I have, so what you can see is that Stephen and blah. Stephen is this massive number. Blah is the other word I want to print out after Stephen, right? So it's not separate, it's separator. So essentially, I can add 1,000 words over here, and I can just keep going forever over here, as long as it's the right syntax, and I'll just keep on adding more and more stuff. But let's say I want to add a dash between all of them. So equal to dash, right? So now the separator between this word, this word, this word, and this word, instead of being a space, which, let me show you, print, separator, string inserted between values, default a space. So this, the string inserted between the values is going to be, instead of the space, a dash this time. And when I press enter, it's instead of it being just a space itself, it's now a dash. And based on that, we can now just quickly, and now we can just like sort of see, oh, this works perfectly for me. That's what I mean by the separator. Does that answer your question, Stariel? All right, great. So now I want to print Stella. So this is my massive program where I have a 50-year-old person called Stella, and what I'm trying to do is increment their age by 1, and I want to print it out. Generally, what I can have is a very, very complicated problem that's like literally 100 lines of code. Yes, I have written a piece of code that was 300 lines once. That was one really bad weekend. Or actually, no, that was just a really bad Monday. Monday jokes, am I right? So what I do now is I can just execute this multi-line program in just one single go, and it'll run. Okay, first line Stella is 50, set and done. Next line Stella equal to 50 plus 1. Okay, so now the new value for Stella plus 1, I got it incremented by 1. 50 plus 1 is 51, and that's stored back in Stella. Make sense? So now I want to print the value out, and this way I can have I've actually written a file from this is stored in a main.py file with all the other information. Right. And then I can just print it out, and when it runs, it first sees, okay, Stella equal to 50, Stella equals Stella plus 1. I got to increase that by 1, and then print Stella, which prints it out. I think Laurie has a question. Hopefully nothing to that. Right. So, yeah, and that's more or less how you use this thing. You can also add multiple files. Is a space between lines necessary? No. It is not. I'm just trying to be clean because I'm a bit of a clean freak. Yeah, space is not necessary. I hope that's clear. You'll notice you don't even need the semicolons even, which is pretty cool. But fun fact, if you put the semicolons between like lines like this, you can run all of them in one single line. People would literally metaphorically beat you. At least my coworkers would beat me if I started doing this because it makes my code look terrible. And one of the main things about Python is that you got to be really clean about it, including this. So, fun fact, between Stella and Stella, that's strings. I won't worry too much about that for now. I don't want to go too much into it. I just want to like sort of, is Stella and, in the group chat, is Stella in quotes a string? Yes, it is. I guess I'm going to talk about this, aren't I? Instead of this cool thing about Python. God damn you, Stuart. Oh, wait. Hi, are you allowed to give a variable with the same name multiple values? No. What I'm doing over here is I'm overriding the previous value of Stella with, I'm overriding the previous value of Stella with the new value of Stella. You are not allowed to do that. And yes, I can have Stella be a string, and it just works like that out of the box. But now if I do this, it's going to break. I can add strings together like this, but if I were to do just this, it would break. And sorry, also this entire thing is buggy. Like, it's kind of buggy, which is why I wouldn't recommend it for actual development. I just recommend this for a workshop perspective. We'll be showing you a piece of code. I'll show you a pretty good resource for getting started with most of the other stuff later on. So right now it breaks, type error, can only concatenate. Concatenate means add them together. String to string, not. So we're adding a int to a string, and that breaks it all up. But if you convert this to a string and add something nice like is number 1, so when I run this, it does Stella is number 1. I forgot the space in the bottom. Sorry, Stella. Stella is number 1. Yay! All right. So just based on this, you can sort of understand how stuff works. Again, I don't want this to go into a lot of different, very complicated thing. I just want to be super, super simple. I'm going to be posting some excellent resources that honestly are just amazing, and I probably can't do them justice in the next. Well, I'm already over time, but I'm not going to, sit over here. My throat's starting to hurt, and I'm drinking water just to ease it out.
You're not over time.
Don't worry about it. You
And
started
it's,
at 7:30.
you started at 7:30.
It's 8:50.
It's 8:50.
You said today was a 2-hour workshop, so you have another 40 minutes.
Another 40 minutes.
Wait, I said it was going to be a 2-hour workshop?
Well,
Damn.
up to you.
Well, up to you.
Make it 90 minutes if you think
you're running out of content.
Nah, I can talk about this stuff for days, but I can keep on going for the next how much ever time you guys want. All right, so Stuart, can you just send me a message with the list of resources that I'm supposed to have. My list got deleted. Cool. So next, I'm going to be explaining if conditions to you and how they work. So an if condition is essentially how you sort of want your program to work without having any. Let's say you want to just. What's a good example I can give? Of an if condition. Let's say you're given a number. So number is equal to 5, or num, or var, or whatever you want to call this. Again, variables, you can name variables anything. So yeah, number is equal to 5, and what you want to do is, given this number, you want to check whether or not this is even or odd. Or, wait, how would I do this? Yeah, so before, actually, let's check if it's greater than 10 or not. Okay, so if number greater than 10, again, greater symbol, what I want to do is print 10. All right, so I run this and it does absolutely nothing. Why is it doing absolutely nothing? Because this number is not greater than 10. I guess I'll start with 15 first. So I run this and number greater than 10. So what happens here is, it's fine, I'll figure it out, Steven. Sorry, Steven just messaged me. Okay. So what I'm doing over here is, so now in the case that it doesn't work out, I'm going to be trying to do another if condition, but I only want it to be checked if the first condition runs and it fails. So for that, I have the elif, which is, before that, I'm going to be looking at the else statement. And what the else statement does is that if this thing doesn't work out, it runs the else statement. So print, oops, less than 10. Run. Great. Oh wait, before we reduce this, run. Okay. So now with my else statement, what's happening is that if number greater than 10, print greater than 10, fantastic. That works. Less than 10 works if the number is less than 10 because 5 is less than 10, right? So now what if it's equal to 10? By default, this is automatically going to run and say, hey, this is less than 10, even though we know that this is because it checks the first one and says, oh, this is not true, and I have to go to this one by default. So what do you do if you want to have some other checks done? How does recursion done in this Python process recursion? Okay, that's kind of out of the loop over here. Higming? I hope that's your right name. How does Python process recursion? That's a bit advanced. I think it's a little bit out of the scope of this workshop as well. You know what? If I get to it, I'll do it. Otherwise, I'm going to link you to this resource for how does recursion work. Actually, wait. How does Python process recursion? XKCD, because darn it. I was trying to find a cool XKCD for recursion, but I guess that doesn't exist. Wait, let me check this one. No, it doesn't exist. Recursion essentially just keeps on going back into its own stack. It's a complicated thing. I don't think I'll have time for it, but they're like, before I started goofing off with XKCD, there were actually some people who seem to know, like, you know, they just have a YouTube channel explaining the stuff. Like, what do I know? Jokes aside, these guys actually probably will do most of it. I suggest this video. What is your hopefully that's a nice one. If not, you can always just Google it and it'll just explain it. No problem, Higby. Okay, so right, back to the topic. If number greater than 10, it doesn't know. But now there's the else if clause, and what this does is that else if number equals to 10, print the number is 10. So just to explain over here, it's an else if. So what a lot of the programming languages do is that, like for example in C, their syntax is if condition else if do this, other condition. So what other programming languages do is that they have the same constructs of only if and else. They don't have an elif statement. So what they do is that they have if condition, same over here, and then an else statement that runs the if condition again. So it's essentially this component just copied over here, and that's how they do an else if block. Makes sense, right? The Pythonic way, however, is saying, no, let's just create a quick component for that and do it this way. It's much better for blah, blah, blah reason, and it is. I won't go too much about it. So that's then they sort of like merge in the else and the if part of the conversation, and they came up with elif. And what it does is that if the first function fails, it moves on to the second elif statement. Any questions about elif? No? I see Steven is typing. Anyway, so what it does then is it does number equal. Yes, elif does not run if the first statement is true. That is true. Nor does else or anything else. So it does not check it. Yeah, even if elif is true. Thank you. So what this does is that it checks whether a number is equal to 10. To equal sign generally means just check if this is equal to this. If it is, then it returns 10. So now it just says the number is 10. So when the number is less than 10, this piece of code will work, and it'll say, greater than 10. If the number is equal to 10, then it'll say number is 10, else the less than 10, right? That's how if conditions work. And the elif statement can be used as many times as you want. And it just works. It always goes top to bottom, and it does not check any of the, and if one of the top ones works, say this one works, it doesn't bother with, it skips over all the rest of these. All right. Yeah. Also, don't forget this colon at the end. It's actually pretty important. In my other Python workshops, almost everyone forgets about this the first time, and it's just like, guys, I just explained this to you like 2 seconds ago. Please stop forgetting it. Why, God, why? So, yeah. So that's essentially if conditions in Python. So I'm going to stretch a little bit. All right. So after this comes the concept of for loops. But before that, I'm going to explain to you the concept of the range function. What this does is essentially return an object that produces a sequence of integers from start, inclusive, to stop, exclusive by step. Range I to j produces I plus 1, I plus 2, all the way to j minus 1. Start defaults at 0, and stop is omitted. Range 4 produces 0, 1, 2, 3. So this is exactly the valid indices for a list of 4 elements. When step is given, it specifies the increment or decrement. So to explain it line by line, what this does is that it range of 10 prints 0 to 10. But then if I do a list, it will do this. Okay. So the range, what it does is that firstly, the list function will execute any function inside it as it iterates through it all. It returns a list object. What is a list? You will understand the book that I'm going to send it to you. Make sense? Cool. Victoria D. Okay. She has a question. I'm going to wait. All right, I'm not going to wait that much. Right. List function is a data type. If you compare 10 equal to 10.0, would it return true or false? That is an excellent question. 10 equal to 10.0, it returns true. Why it does so is because it compares their actual value to be the same thing. So similarly, if I do 5 over 2 equal to 2.5 equal to 2.5, it's going to return the exact same thing because it evaluates both of the operations and validates that they are mathematically equal in value. Similarly, I can also compare strings. Testing equals to testin plus a G. By the way, for strings, you can have them be double quotes or single quotes. And it'll assert to be true because it evaluates this operation for this operation and this operation. See that I need to do an add over here and then merge them together and then see that both these strings are the same. That's how strings work in Python. Other programming languages will have, say, testing. Assuming I put a dot equals and then just compare both of them, don't bother with it in Python because it just because it believes in having one function that does one thing and one thing well, Pythonically. Ooh, that reminds me of the Zen of Python, which is really cool. It's the design philosophy for Python. It's in this really cool poem. I don't know. I like it because it's cool. You can also, if you do import this, it will automatically print out the entire poem. I suggest that you guys read it if you want to use Python effectively. It just believes that the beauty of the Python way is the fact that you can actually read it really close to actual reading, code. Like it's a pseudocode, and yeah. So, I was explaining range. So let's see if xrange is still available. No, xrange does no longer work. So what the list function does is that it executes a thing. Just remember that. And it returns 0, 1, 2, 3, 4, 5, all the way to 9. So I can do range of 1,000, and it prints out 1,000 numbers. And I did that to this poor machine. So range function essentially prints out the entire sequence. Anyone have any questions? Let me know right now. I don't see anyone typing. I'm going to zoom to the video. So let's say I want to go through this I want to go through this entire range value and add a number to it. Let's say I have a number called, let's say I want to find out the sum of all the numbers from 0 to 1,000, right? So let's call that sum count equal to 0. And for a variable, I got to pick a variable now. A random variable off the top of my head. Let's say I in range 1,000. Remember, it goes from 0 to the stop number, which is 1,000. So I need to go from 1,000 plus 1, right? Sum count plus equal to I. And then print count. So, just to be clear, these spaces are just to make sure that my code is clean for no other reason. I believe that clean code is the first thing you got to do to make sure that your code is working well. So sum count is equal to 0. That's pretty self-explanatory. We set a variable equal to 0. Then for I in range, so each time you want to access this value I in our for loop over here, what it does is that I is assigned a value starting from 0 and ending at 1,000. And then we can use that in our thing, in our variable, our for loop. We do sum count plus equal to I. So what that means is that it it takes whatever value is I and adds it to sum count and keeps on repeating it for all the values in this 1,000 range. And then we just hit run, it executes it, and it's, that's pretty cool. And it is 500,500. That's pretty cool. And if I want to keep expanding this, say 1, 2, 3, 4, 5, 6, for 1,000,000, I run it again, and yeah. Well, it's actually a pretty cool math thing I just learned today. Okay, and that is 1, 2, 3, 4, 5, 6. It's a big ass number. I'm not going to bother counting. And yeah. Remember, it might end up being a little bit slow because it's running on a web browser, but like in actual Python, it would actually be much, much faster. And to sort of like show you guys this just for the hell of it, so this is going to be tiny, but I'm essentially copying the same stuff from here line by line. Sum 0 equals 0. For x in range 0 to 1,000,000. Sum count plus equal to I. This actually is slower. Interesting. All right. Yeah. Sum count is that. It was slower than I expected. I'm sorry. I thought it'd be faster. But it is iterating through the entire list. So yeah, a faster way to obviously do this is using another built-in function called sum. So sum of range 100 will essentially just quickly compute the numbers right out of the bat. 1,000. It's 1,000 plus 1. So yeah. That was how many zeros I had, right? Let me copy this. And then just to sort of show you guys an important difference between Python levels, Python speed, and the C level speed that I was talking about. So you can obviously see this one was done, like this sum was done much faster than this sum over here. The reason is because, as I explained before, a lot of Python stuff is abstracted for the user and is written in C itself and made to execute that way. What's going on is that essentially what Python does is that it needs to check what the type of this object is, whether or not it's a string or an integer, blah, 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 and when it does this incremental operation. That greatly slows down a lot of the processing that takes place and is just a huge pain in general. The sum function, however, assumes by default that this I value is going to be an integer or a number itself. So when it does this plus operation, it just knows for a fact that it is and doesn't bother checking, and that way you just get this massive speed boost. Again, it's the same example that I was talking about, how Python can be made faster if you just know what you're doing. I've actually written Python code that is much faster than my C code because I just know Python faster. I just know Python better, and because of that, I can just quickly just get up and running with it. So yeah. So kind of surprised it took so long. It's like about 1 second compared to like this function, which takes 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds. So you can quickly just see how fast these two are, just like a simple comparison like that. Right? Any other questions about for loops especially? I'm waiting. Anyone have any questions? Just let me know. I'm just gonna get up and get another glass of water. Wrong throat. Also, if you guys have any other topics you want me to cover right now, that'd be pretty good because I'm just about to start wrapping it up now. All right, Stella has another question for us. Ooh, what book do you recommend for learning for Python? I was going to get into that. Automate the boring stuff with Python. So, this book is one of the most highly recommended books I know of in general. Like, what does plus equal to do? I'll start off with that one because it's an easy question. Plus equal to. So in the past, you saw me do sum count equal to sum underscore count plus I, right? So instead of doing that, instead of typing out this massive thing, what the clever people at Python development said, hey, instead of that, let's just have let's just have this one operator that just adds things up really quickly. Okay, I'm sorry. I started looking at Steven's thing for C++, and I have no idea what he means by it. Okay, I need to block Steven now because I think he's making a really bad joke. How do I block the admin on this? And no, the plus plus thing isn't something that you do. I have no idea what's going on. Right. So that's essentially what the plus equal to does. It also extends to the negative and extends to the times, so you can do it that way. Fun stuff. So what's interesting about this book is that you go through the entire list of chapters in it, and you see that from 0 to like 11, it's just the introduction to programming. Again, this is one of the most highly recommended books. It's completely free. You can just literally click on any of these links and be explained by someone in a really clever and clear, concise manner about what stuff is and how stuff is done, line by line. Highly recommend this book to all beginners. I had people tell me that this is one of the best books that they started off with, and then I introduced them to another book that isn't under the Creative Commons license, but is by the same publisher and I think writer, and they just loved it. The name of that other book is Python for Beginners? Yes, I don't know how to spell it. Python for Beginners, no, Start Press. Python Crash Course, that's the one. Like, this book is also pretty good. If you can find it through some means of, say, purchasing it, I highly suggest it. I hope you understand. I hope you're able to read between the lines, blah, blah, blah. Yeah. Automate the boring stuff. Thank you for putting up the link, Steven. You know what? I'm going to start calling you Stuart now, just because. Sorry, that's me. I shouldn't do that. Right. So just this way you can sort of, for the first, I would say 11 chapters, you gave really good understanding of a programming language and how it all works together. I highly suggest the other book, however, as well. If you're able to find a link that is reputable, that would be great. These guys are really amazing. I highly suggest that you buy their books, but if you can't, that's fine as well. The other one is Python Crash Course. Crash Course 2nd edition. No, the other one is also good for beginners as well. It's perfectly, yeah. Both these books are amazing, and this is the free one. This one over here is just for beginners. And I would upload my copy if it was allowed, but I should not be saying that on anything. Anyway, I highly suggest you guys read this book. And I'm pretty sure you can find the PDF. Yeah. Yeah, we're holding Steven accountable if the cops come after me, okay? Like, this is our agreed upon thing. Like, everyone has to go with it. I will totally not be sending Steven a copy so he can just leak it onto the group. Totally not doing that. That would be so mean to the publishers. But seriously, these guys are amazing. I bought their books online because of how much I like these guys, and their library of stuff is amazing. Sorry, completely on a rant there. The next is, if you're more like me and prefer YouTubers, I suggest that you look into Centex. He's a really great programmer who goes into all these wonderful tutorials. his most famous ones that I really liked. Oh my god, he does quantum computing, guys. Come on, that's like in BCI, self-driving cars, facial recognition. It's all cool stuff. But learn to program with Python 3.7. Ooh, he updated it with his latest one. That's actually pretty good. Because yes, Steven, I agree. Hearts all the way. He's really good. He does some other stuff as well, but I mainly suggest him for Python because he covers a lot of topics and he's really, really great. And yeah, seriously, quantum programming. I mean, it's beautiful, man. Quantum computing. I mean, if I knew what I was doing with that, I'd probably do something cool with it, but I'm going to pretend that I am. So, yeah, that's more or less for a workshop. What other resources do I recommend? Oh, there's also a Curious page to learn resources. A good chat. Okay, so I'm just going to literally copy this for Panther 5252 chat room app Python. And paste it over here. What's the first thing that comes up? Yeah, literally over here, chat applications page. And then there's some projects over here. Oh, you're saying that he makes? Oh yeah, he does. Yeah, I thought you were searching for one. Yeah, he covers a lot of different things, like we said. I think he's using he's using Kiwi. Yeah, sorry, Panther. I thought you were asking. Yeah, so he's even got his own website where you can sort of like go through his stuff and then have a look at all his stuff over here. Have a look through all of his text, like just the line by line explanations and everything for it. Tech with Tim, I've never tried him out. If he's good, man. I'll take your word for it. What else was I thinking? Why do you have range 1,000 plus 1? Excellent questions. So, like I said, trouble with names. So, the way the range function works is that it essentially takes you from 0 to whatever number you want, minus 1. And what we're trying to do is essentially add all these numbers up, starting from 0 to say 100 in this case. 0 to 100, and I run this. Oh yeah, I'm doing times. Run this, and it goes 50-50. That's because, exactly, so I'm trying to avoid the, yes, Stephen, 1,000 plus 1 is the same as 1,001. So you're trying to avoid having one less because of the 0 index. Exactly. That's exactly what I'm trying to do over here. Yeah. So yeah. So I know what you guys might be thinking now. Oh, how do I, start developing? And let's say I want to start building a chat room with it. How do I do that? I'm just going to show you my professional work environment that I use. Yes, I have a fun bunch of wallpapers. So I'll just work with this. This is probably going to scare you more. Sorry. All right, let me just open up PyCharm. So, PyCharm is opening up. This is, by the way, Jupyter Notebook. It lets you run individual code cells without having to run the entire script. Pretty useful for big data stuff, which is what I do for the most part. Yeah, I still enjoy it. I dropped my pencil that I was playing with for the entire presentation. Excuse me. All right, so that's going to open up eventually. So before that, I'm going to introduce you to Conda Python. So a lot of smart scientists started to realize that for scientific computing and working on these complex projects and stuff, I want to install, say, Curvy or whatever. So the one that it's essentially a package manager. Sort of like the App Store where, actually, you know what? Look into Anaconda when you want to start working on projects. It's just much easier. You find one of these professionals explain it, but my explanation is essentially it is a distribution of the Python and R programming languages that aims to simplify package management and deployment. So a lot of cool libraries like Dask are kind of hard to install on your own. You need to make sure that you have all their weird dependencies set up and stuff, and that's a pretty big pain, especially for stuff like OpenCV. Like, that's a huge pain to do on your own, and I do not recommend that you spend the time and effort to do that. As a matter of fact, let's try installing OpenCV right now. CMD, command prompt. What if you don't want to start at 0? For that, you can just sort of specify what the number needs to be. So right now, it's start, comma, stop, comma, stop. I didn't go completely. I think that's too advanced for beginners. You know what, Steven? You might be right. That is a bit too advanced. Yeah, I know you're talking about. I know you're talking about packages. Yeah, but it's really cool. Okay, just like when you start working with packages and stuff, start looking into Anaconda and figure it out, because there are these great tools that explain Anaconda. Just yeah, it's a bit advanced, but when you get to it, you'll really like it. I think it's one of the essential stuff that you need to work with Python. That's my opinion. So back to the range function. For I in range, 1, 1000. This sort of starts off with 1 instead of 100. And you still need to add the +1 because the stop function still stays the same. So when I run this, it's going to be now 50. Oh, yeah. All right, let's start at 2 instead. Yeah, so 5049, right? Because remember, the first one was 0, and when you add that, it stays the same. So yeah, and then let's say I want to only consider the even numbers, right, for this entire operation. So now it's going to be 2, skip 1, 4, skip 1, 5, no, skip 1, 6. Then 6, skipping 7, 8, skipping 9, 10. And that's how it's going to add all the way to 101, which it will probably skip 101 as well. Let's run that again because of the weird thing. And yeah. Oh, PyCharm's open up. So this is a very simple weather bot that I was writing a couple of days ago for an automation project that I'm trying to do. This is PyCharm. It's this fancy little thing. This is right now running Flask as the main application to do most of the stuff. And could you re-explain the number skipping, please? All right, if you're going to say please, then I just have to do it. So, hopefully this will make it much clearer. I should probably do 10. Yeah. So, generally when I do 2 to 100, it's listing 2, 3, 4, 5, 6, 7, 8, 9. So it lists all the ones from 2 to 10, not including 10, of course. And yeah, so it lists all these numbers, right? So let's say instead of that, I want to skip a number. What I do is I say, what it does is that it starts off with 2, skips 3 and goes to 4, skips 5, goes to 6, skips 7, goes to 8, skips 8, goes to 9. And based on this, I'm able to follow along what exactly is going on. Does that help? Jastly? Again, terrible at names. Great. Any other questions for anyone else in the audience? Okay, I'm going to go back to explaining what this stuff is. So to help you guys understand as well how GitHub comes into all of this, I'm going to go to my GitHub account. For joining this group, you are now expected. What does for function do? The for function essentially goes over. For is a keyword. What that means is that it has a special function that it's built to do, and this says that this operation has to be repeated time and time and time and time again for this iterator over here, right? Can you let me know if that works for you, Smexy? Right. So what it does is for each individual value, it goes through this entire list over here that we sort of showed is 2, 4, 6, and 8, but all the way to 100. Assigns I to that value. Some count will increment that into the overall thing, and the for loop just specifies that it's a loop that does it again and again and again. I hope that explained it. It's nice. So back to GitHub. So this is my GitHub page. What language are you using? This is Python. Great. This is my profile. I just want to sort of explain to you would this be the one? All right, I have a bunch of projects. I'll start off with this one. This isn't necessarily my project on its own. This is somebody else's project that I sort of forked, which essentially means that this guy, Mitmo, however you would say that, had a repository. And what I did was I said, hey, this is a really cool, and I said to myself, hey, this is a pretty cool thing. What I'm going to do is I'm going to make a fork of it, which means I'm going to copy over his code as if it was my repository, and I'm going to start making my own modifications to it, which I never got around to doing because life. And he had this entire particle physics thing where he like simulates gravity between particles based on their distance. Really cool stuff. Right. And this way I was able to sort of like follow along and understand exactly, and like understand his algorithm, and I was like, pretty cool. I was like, hey, this is pretty cool. What was I going to show you? We shared an organization. Yeah, I think this is, yeah. Weather API. Right. So this is my GitHub repo for it, and what I intend to do, what this does is essentially contains my code and how it's been set up. Steven, are we out of time? Is there a problem if I go over?
Keep it short and sweet.
It's almost been 2 hours.
So after this,
All right, cool.
I would say just
conclude by listing
the resources so people can keep learning about
Python.
Python.
Sorry, the echo's really bad.
Oh yes, that's fine. I mean, it's your problem. So this is GitHub. You can upload your code over here. You can start working on stuff over here. I write this code over here. This thing identifies it, version control, let me upload it and make my changes. And it'll say, hey, this is this piece of change over here. I can be like, nah, I don't want that change because it's stupid. Blah, blah, blah. Again, keeping short, going through all really fast. This is all just some basic and interesting stuff. Right. So I wish I had more time to go in depth with you about this stuff, but I guess I'll have to hold that off for later. This was my Learnathon. I hope you guys enjoyed it. We covered quite a lot of different topics over here. I hope you guys learned something new. Yeah. If you guys have any questions, let me know. I'm probably still going to be joining on the thing. Steven was nice enough to post all the resources, but I'll talk about them again. There is PyCharm, which is pretty cool. It lets you do stuff. Thank you, Sir Ali. Nope. Chardora. Wait, is that you, Charlotte? Is your name Charlotte Dora? Hey, Charlotte, it's you! Oh my god! Well, I'm happy you were able to catch the workshop. Sorry, she's a friend. She's a great friend, actually. She's amazing. What was I going to say after that? Right. So, yeah, PyCharm is one that's really useful. There's a community edition, which is pretty useful as well. After that, we have automate the boring stuff with Python, which is pretty useful as well. After that, we had Python Crash Course PDF. Oh my god, I put a PDF there. I'm so sorry. Please don't click on this specific link that might contain the link, or don't follow along what Stephen will send you later on, explaining with a link to maybe the actual book itself, because we're not allowed to just read them that way. Then after that, we had Sendex, who has some pretty amazing resources on Python projects. Pretty cool guy. I highly suggest him. Oh my god, his actual name is Harrison Kinsley. More you know. Right. And for any other questions and stuff, I'm going to be trying, just let me know in the messages. My name is Ali. I'm one of the mentors. Let me know. Just send me a PM for any questions or anything. I'm more than happy to guide people for projects and stuff. I just like doing it because it's nice and giving back to the community, right? Yeah, that's the end of my workshop, guys. Yay for me. Yeah.